Hello students, this is our video for 15.2, Drawing Cubes and Rectangular Prisms, which is found on page 263 in your textbook. As you can see in this lesson, they use dotting paper a lot. It's helpful for drawing cubes, especially as we're just getting started with cubes. Unfortunately, I don't have any dotting paper, so I made my own. You can see that I'm still able to make errors, which I did there, and quite a few down at the bottom of the page, but we got this whole sheet to work with, so let's see how we do. Now remember, unit cubes are what we use to build up bigger shapes, and they're helpful for measuring their size and comparing them. So this is an example of a drawing cube, which also we called unit cubes in the last lesson. And just very briefly, how to draw these. You can really just take any four dots that are closest to each other and see how these are parallel lines and these are parallel lines, except for my little fluke there. And then this edge would be shared with another shape, and rather than drawing those lines extended to be more parallel, I'm going to curve them like that so that these are not parallel lines anymore. And then we can already see two faces of the cube, and we just need the top of it right up there. Okay? Once you've drawn one cube, you can actually pretty easily draw more. If you remember in the last lesson when we had cubes, you couldn't see all the faces. So if I'm going to draw a cube beneath it, I actually just need to show these two faces. Like that. And I can see that there's two cubes stacked on top of each other. I'm going to grab my orange pen for a minute. There's another face. If you're just drawing that bottom cube, you would need to draw this as well so you could see the top of that cube. But this blue cube on top is covering that bottom, so we don't really need to see that. Similarly, if you're drawing a cube and you wanted to draw one next to it instead of on top of it, here's my original cube. I'm going to draw one that's next to it over here. And actually, let me use the purple pen to do that. The top base is going to be right next to it on top, so you can see they're next to each other. And these two faces are next to each other. But the face that would be right here is being hidden by the blue square, and so you're not able to see that. So you would just see, without the dotted lines, those two shapes next to each other. Okay, let me draw an example of maybe these two shapes combined, but without those dotted lines. So I would draw, this is the cube that's going to be sitting on the top level, and then we've got one underneath. And then we have one next to it right here. And actually, normally, if you look over here, see how I would draw the rest of this top? But here, the top of this has been covered by that top cube. So all that you could see is this very top cube, which is covering the top face of this one. And then this poor cube here is losing its entire face to this shape and half of its top to this one up there. So it's a little bit confusing seeing a 3D shape like that drawn 2D. Now, sometimes, because that is confusing, we'll actually draw these shapes, but without all the extra lines for the unit cubes. I'll give you an example. By drawing a cube still, so it's made up of faces that are all squares, but it's going to be too long and too wide. So if it's too long and too wide, it'll be easiest to draw the top of this cube first. So there's the top, right? It's each edge is twice as long as this small red cube up there. That means that the height of it will also be too tall, and the width as well, like that. Now I am actually just going to draw a little unit cube so we can see how they would build up to this. But for now, see how much clearer this is, where you can just see the only lines that make the edges instead of all the extra ones. Now if I use some dotted orange lines to draw all of the lines for the unit cubes that make this up, it would look something like that. Which can also be useful if you're trying to count up how many unit cubes make up this whole cube. If you remember from the last lesson, I can see 4 on top. I can see 3 on bottom, but there's one that's holding up this back cube. So it would take 8 of these small cubes to make this large cube. But I don't always have to draw those dotted orange lines, and sometimes it's actually better to not. So another example that they've drawn for you is one that's quite a bit taller. So let's make it 1 wide still, and 2 long. Let's make it 4 tall. So each of these lines down need to be 4 long, but the width is still the same at the bottom, and the length is still the same over there. So this would be made up of quite a few little cubes, but I don't have to draw all those lines. It looks like a cleaner drawing. And let's draw a one that's laying down, but also is quite long. Let's make this one also a little bit wider. So it's like the cube that I drew right up here, where one face is 2 by 2. But let's make this one as deep as this one was tall. So let's make it 4 deep. 1, 2, 3, 4. And then it might be tempting to draw this to the same length, but notice that the starting point is 2 back. So 1, 2, 3, 4. So from this point, it's 4 deep. From this point, this one would be 4 deep. And it's still 2 wide and 2 tall. So again, this would be made up of quite a few different unit cubes, but we don't always need to draw that. Sometimes you might actually be asked to draw something, or the missing lines. So as you can see here are 3 shapes that have some lines missing, so it's not a complete drawing yet. And by missing lines, they don't mean drawing all the different unit cubes, but instead draw the missing face of the shape. Because right now, this just kind of looks like a piece of paper that's been folded once down the middle, doesn't it? I need to make this a complete 3D shape. So I've got this face that's kind of over here. I've got the one on the top. I need this one on the side. How far down should this go, and how can I find that information? If I look at how far down the other face goes, went down 1, 2, 3. So 1, 2, 3. And I can just connect these lines, but let's make sure that's correct. On the top is 1, 2, 3 wide. 1, 2, perfect. 1, 2, 3. And that looks like a normal 3D shape to us, doesn't it? It is true that sometimes maybe you'd have a missing square or something, but for these drawings, let's assume that these are rectangular prisms, so don't worry about any weird shapes. So let's look at this rectangular prism that we need to draw. We've got 2 sides already, and in most of the ones that we've drawn so far, we're looking at where you can see the top of these shapes, right? Top, top, here's some tops, top, 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 top. There's a top. This one, I can't really draw the top, right? It looks like we're almost looking at it through a glass floor, because this would be the bottom here that we're missing. So how big should that bottom be? Well, it looks like this width is too long. And so if this is a rectangular prism, then this also has to be too long like that. See how this length is the same as this other side? And then this length should be the same as this side, which is also 2. 1, 2. Now we can start to see this as a 3D shape, where we just couldn't see the bottom base of it. Now looking at this one here, this is one where we're missing the top. Again, it just looks like a piece of paper that's been folded right now. So it's pretty thin. It's just 1 across. So let's go to the back and make it 1 across. And then this side is 3 long. So 1, 2, 3. There we go. Looks kind of like a cereal box to me. It's nice and thin. Last one we want to do is down here at the bottom. I've got 1 unit cube, and the instructions, if you can read that, says I want to draw something that's 3 times as long as these edges. So each edge needs to be 3 times this size. Excuse me. So in this little unit cube, each one is just 1. So each of these sides, and what I'm going to draw, or each of these edges, has to be 3 long. So 1, 2, 3. 1, 2, 3. That just barely fits. And then 3 tall. 1, 2, 3. And actually I can do 3 tall from this point too. 1, 2, 3. And there's one other point I could do 3 tall from. Where would that be? That'd be this other vertex or corner over here. 1, 2, 3. Now I know the width is 3 on all of these, so here's another 3. There's one. And now it's actually starting to look like one of these up here where I'm just missing one face. And that would be the top of it. 1, 2, 3. 1, 2, 3. There we go. That looks a lot more than 3 times the size as this one does, though, right? Did we do something wrong? We actually didn't, because we can see 3 times as long as these edges. You could fit a lot more than 3 of these little cubes in this big box. But each width is, let me get my orange pen again. There's 1 cube, 2 cubes, 3 cubes. So this width is 3 times the size. 1, 2, 3 again. And it's this 1, 2, 3 deep. So even though this looks way bigger than 3 times the size, I've followed the instructions and each edge is 3 times the length. All right, your homework pages for this are pages 169 through 172. Lots of drawings, lots of big pictures to draw. Please do that, correct it with the document that I've uploaded, and then watch the video with any remaining questions that you have. Thanks, 5th grade.